Morning, everybody. Time is 35 minutes, and I have to talk about why technology is the mainstay of APA. And like what Tony said right in the beginning, technology will definitely bring about a certain capability which is very sophisticated and which can be the winning edge in a war. But it may not be sufficient to give you the strategic victory that you need when you go to war. So those are two separate things. What I will talk about today is about how technology has empowered APA to bring it to where it is today, and how APA itself has changed the way we decide to fight a war. The advent of military aircraft has been slightly more than a century, and it's just about a century since we established the world's first Air Force. Invented in 1903, adopted by the military in 1908, first time used in combat in 1911. So the aircraft is relatively new. The maturation of air power as an instrument initially of the military and subsequently as an instrument of national power by itself has taken just about 90 years, and it can be thought about as a revolution in thinking about how you project power. And like the potential impact of the computer, the impact of air power on national security as well as on the defense forces was kind of initially missed. In 1945, the National Research Council stated that the US would not need more than 5 or 6 electronic computers. And you can see what's happened now. And similarly, the impact of air power on military affairs was not really seen by a large number of strategic thinkers. The impact of air power is therefore one of the impact of technology on the way in which you conduct a war. It improves the efficacy of the application of force, and it has an indirect impact on the strategic results that are achieved. Although the direct impact of technology as far as air power is concerned and how it is applied really is at the operational level. And at the strategic level, you find that technology changes the force structure, it changes the force posture, it changes capability development, and underlying all this, it changes the way in which we ensure national security. So through air power, technology affects these things. What I plan to do in the next 25 minutes is to look at the development of air power through the prism of technology. How does this, how has technology affected the way in which we apply air power? And very briefly, at the intertwined relationship between technology and concepts and the concepts development that we undertake. It's a universal truth that developers and demonstrators of new technology are always faced with a certain amount of skepticism and at times even a certain derision as far as acceptance of their new ideas are concerned. In August 1783, the scientist J.S.E. Charles flew a small unmanned hydrogen-filled balloon over Paris. Somebody who was standing, a bystander who was standing and watching, said, "Of what possible use is this?" And it is reported that Benjamin Franklin was very close to this gentleman who said this, and he is supposed to have snapped back to say, "What is the use of a newborn babe?" So that's how the whole thing started. The balloon created an observational vantage point, and that is the beginning of the rudimentary ISR as we know it today. In the 1890s, the potential for a controlled vehicle was realized, but there was no technology available to do that in the 1890s. And the revolution in propulsion, structural concepts, and aerodynamic theory had, within a few years, the Wright brothers getting airborne. And very frankly, I'm tempted to stand here and now say 1903, the Wright brothers flew, and the rest is history. But that's not really what we want to do. So in 1901, before the first flight took place, A.G. Wells had this to say, very precisely, that by 1950 at least, we should be flying. Just as an aside, A.G. Wells is also the first person to use the term air power in a book that he wrote, The War in the Air, in 1908. And despite the skeptics, in 1911, the Italian forces used the aeroplane as a weapon of war for the first time. Then, to deny the use of this observation platform led to arming of other aircraft and led to the concept that we know today as control of the air. And technology was concentrated on structural refinement, on propulsion, and on weapon system development. This is what the concentration of development was as far as technology was concerned. Came Second World War, and the Battle of Britain and the strategic bombing campaign both proved and disproved some theories. But from a technology perspective, the invention of the radar and the Norden bomb sight are noticeable or notable developments that took place. And of course, propulsion efficiency improved, speed improved, range. And at the end of Second World War, from a conceptual idea of having catastrophic force, we actually got the means to have catastrophic force, the atomic bomb. But what we tend to forget when we discuss this, the nuclear use of nuclear weapons, is that the delivery system was air power. How did air power that was only able to cross the English Channel at one stage now was able to go and apply this catastrophic force? And that is a technological marvel by itself. After the Second World War, the famous JFC Fuller, he did an analysis of armament and its influence on history till then. And he had this to say, the italics at the end are my own, the emphasis. But basically what he said is that the whole question of weapon and weapon effectiveness is based on range. And range meant aircraft at that particular time in 1945. So from this, in the post-World War II area, we went on to have a high-speed revolution, turbojet engines, transonic aerodynamics, like the swept wing, and these two things brought about what we normally refer to as the jet age. And then came the concept of air-to-air refueling, which made air power have almost global reach. The combination of electronics and then subsequently computerization started to come together to create smart aircraft with smart weapons. And then came the precision revolution, where air power really achieved maturity. Now, if you look at the four basic roles of air power or air forces, control of the air, strike, air mobility, and ISR, as we accept it, we find that technology has really enabled us to achieve these roles in a much better fashion than what it was before. Before we look at these four roles, I want to talk very little about what we call the information age. The question of wanting to have information is not new. Successful warfare has always been about acquiring and exploiting information. And today's conflicts are all information intensive. And the emergence of what we call today as cyber warfare has made information dominance assume much greater importance than it ever had before. The first use of a balloon, the first use of an aircraft, the first use of an orbital spacecraft. It was all to get information. The first roles that these things played was all to get information. So that is one. And ISR, along with command and control, communications and computers, I believe are the central nervous system of joint combat operations. And if it is so, then air power dominates the spectrum today. The question of ISR, computers, command and control, and communications is completely dominated by air power. I'm not saying Air Force, please note. I'm saying that air power dominates the spectrum. So that is the question of information age and how we use air power there. The question of control there, the essentiality of air dominance. It's the single most important and enduring requirement of air power, ensuring air dominance. And I believe that control of the air is necessary to exert national sovereignty at any given time. So air dominance, you find a lot of terms: air dominance, air supremacy, air superiority. Basically, they're all meaning control of the air, but in different degrees. Air dominance to air superiority. The question of air superiority, not from air dominance, but when you say air superiority, what we are saying or what we are accepting is a certain possible rate of loss of air combat systems that may not be acceptable to us. So air superiority may not really achieve what we are trying to do. That's the first thing. More importantly for the topic that we are discussing today is that even to get air supremacy or air superiority, technological superiority is a must. This is one thing that has been kind of swept under the carpet or gone into the forgotten part of our brains, because for the last 30 or 40 years, no Western forces had to fight anywhere in the world without having complete air dominance. Therefore, people who don't deal with air power tend to take that for granted. I will come back to this a little later when we start talking about UAVs and UCAVs. The problem with air power and technology, the combination, in creating air dominance or air superiority, is that it's directly impacted by the industrial decision making of the nation. By industrial decision making, I mean the ability of a nation to harbor technology, to generate technology, and to accept technology. Unless you can have these three, air dominance or air superiority or even a favorable air situation, may not be in the offing. That's one. And secondly, the doctrinal and operational concept development of the larger military, of the joint military force, will obviously have to take into account the ability of its air power forces, not air forces, air power forces, to create the air dominance required for you to succeed. So that is the second impact that technology has. And what I wanted to emphasize is that unlike in the case of a lot of other force projection capabilities, air power takes a long time. Its gestation period is much, much longer than any other kind of force projection. The system acquisition and operationalizing the system takes a long time. In 1945, from an air power perspective, it used to take 2.5 to 3 years to operationalize a system. Now that time frame has actually gone up to between 20 and 22 years. So that's something that we have to keep in mind. The question of air defense. There are three requirements for air defense. When you say control of the air, it's slightly different. I will point that out now. The air defense, you need to be able to defend the national airspace. You need to be able to defend the airspace above the surface forces, our own surface forces that are deployed. And you need to be able to defend the forces that are undertaking air operations, which is once again something that is not really factored in when basic thinking is taking place. So, to extend this control of the air over the adversary's territories, when we are saying that we are going to defend our airspace, so are the adversary going to do the same thing. And what we need to do in order to be successful is to be able to extend this control of the air over the adversary's airspace as required, which is what we talk about when we say offensive counter-air operations. And with technology has come the ability to carry out suppression of enemy air defenses, which is a prerequisite now to have control of the air over the enemy's airspace. This brought about the evolution of what is talked about as the fighter aircraft. Because when you talk about control of the air, when you talk about air defense, the first thing that comes to mind is a fighter aircraft. All through the Cold War and well into the 20th century, two distinct types of fighter aircraft were developed. One is the air superiority fighter, agile, meant to fight and obtain control of the air. And the second is the interceptor, which is a long-range, which had long ranges to intercept incoming bombers with radar homing missiles, as well as BVR or beyond visual range air combat capabilities. I will skip through a whole lot of other things in terms of missile defenses, but I wanted to put this up in terms of strike precision-guided munitions. In World War II, the precision dive bomber would place 50% of its bombs 1,000 feet, within 1,000 feet radius of the target. And in World War II, to have a 96% assurance of placing 2 bombs on a target 400 feet by 500 feet, you needed 608 bombs to be dropped from 108 B-17s. And in the Gulf War 1991, you could do it with 2 bombs, 1 aircraft with 2 bombs. Operation Desert Storm, 9% of total weapon tonnage dropped were precision-guided munitions, and they were credited with 75% of the damage that was done. In 4 years' time after that, deliberate force in Bosnia, 98% of the munitions dropped were PGMs. So, uninhabited aerial vehicles, if there is time in the question hour, I'll come to that. I just wanted to put this phases of evolution up. I have named them early mechanical, advanced mechanical, electronic, and then early software and developed software. I will not go through it. It's kind of self-explanatory. The operational capabilities as they increase, as they improve, and then come to the advanced software where fully autonomous flight and inclusive situational awareness is what we are talking about. Essentially, what I'm trying to say is that in the early mechanical and advanced or the developed mechanical time, you had a human being applying air power and pushing the envelope of the aircraft. What is the performance envelope of the aircraft? Once you come to the advanced software air power situation, you have a human being pushing the envelope with a computer. So it's a combination of the individual and the computer that is creating the air power capability or expanding or contracting the airspace or the battle space as required. So the cumulative impact of the technological evolution has been to enable air power to determine the new and evolving dimensions of the battle space. Air power, human beings and software together now controls the spread or the bringing together of the battle space. And the singular capacity makes it a politically attractive, cost-effective instrument of national security, capable of effective and efficient application in a host of different environments. So from being a purely observation balloon, this is where we have reached, purely because of technological innovations and the ability of the human beings to accept innovative technology. Thank you very much.
Thank you very much, Sanu, and particularly keeping on time. So please can I call for questions now from the floor. We've had some good presentations to start, to get things moving along, so please raise, okay. So gentlemen, one and then two others. Please remember to introduce yourself, and the microphone is only for recording. It doesn't, so you need to project your voices.
Thanks, Sanu, for an excellent presentation. Peter Hunter from Defence Science Technology Group. I was particularly struck by your concluding commentary there about the efficacy of the air weapon and being politically attractive because of its ease of application and the notion that it can achieve such effects at low cost. My question is to sort of attempt to build a bridge from that notion back through Trav's depiction of disruption, or to put that slightly differently, the sort of Van Crevel seesaw effect of changes across technology. Back to Fozzie's introduction about the risks of conflating the idea of military effectiveness with strategic effect, the kind of the Vietnam parable he erected. There seems to be an important gap in that space where the risk of overpromise and under-deliver of an efficacious air weapon can be very attractive to political decision makers. Ask me how I know. There's a risk there of if the weapon is easily deployed and promises to deliver strategic effect. How do we, as a sort of strategic thinking group, highlight that risk, that effectiveness, technologically enabled military effectiveness doesn't necessarily guarantee strategic outcome?
Yeah, the first thing that I will tackle is about the question of overpromise and under-deliver. Those days are gone as far as airport is concerned. We deliver what we promise. That's something that I can say with a great deal of confidence. The second thing about understanding the effects that are created and whether they are strategic effects or not. At the end of the day, air power continues to remain an instrument within the military force. And whenever military force is applied, or any other element of national power is applied to secure a nation, it has to be a political end state that is aimed at. If you don't aim at a political end state and create an effect by destroying something, or even by coercion, it may not lead to strategic victory, as what Tony said. So I'm not for a moment saying that you can apply air power and then assure the government that you have victory. No. We can assure the government that we will have victory from a military perspective. We can even create a situation where you can have unconditional surrender as the military end state. We can get it. But whether that unconditional surrender is going to give you a strategic victory or not, I cannot say. That is a political decision to make. We can influence the political end state to be achieved to a certain extent as a military force, but beyond that, we cannot. So the use of air power as a first choice weapon is for different reasons. It is not really to achieve the political end state alone. It is because there is now a reluctance in the Western democracies to accept attrition. And the least attrition to your own forces will come if you use only air. We don't want body bags coming back. It's not an acceptable thing for the political leadership. And that is the reason why air power has become such, let's say, such an attractive proposition. You do not have a footprint in the adversary's territory. You do make mistakes. We are still investigating the 200 people that died 10 or 15 days back of an airstrike. But those are, once again, if I'm going to be saying this, I can split hairs and say that that is not an air power mistake. It is a mistake of intelligence. It is a mistake of whoever targeted that. Targeting is not something that is purely air power. Targeting is not a wider equation. So, yes, air power is attractive. It will be used more and more. Whether it will achieve the political end state required or not depends on the connection that we can have between the effects to be created and the connection between that military effect and the political effect.
Thank you. Travis, next question. Travis, and then one question at the back.
Yeah, Wing Commander Trav Allen. Just a question for you. So the initial development of air power was a nice mix between the adventurous spirit of the airmen that were flying these contraptions and the engineers that was developing them. Do you think that, because I believe we continue to develop, we bring in people that have an attraction to flight, who want to be pilots, who want to enjoy the spirit of flying. Do you think we'll actually start seeing a divergence between the engineers which are responsible for the furthering of air power technology and the airmen that we recruit to actually employ that technology? Whereas previously they were beautifully in tangent, but now we'll start seeing a divergence away from the airmen who employ air power and the engineers who develop air power.
I think we're coming full circle. If you really look at the 4.5 generation aircraft that we have at the moment, you'll find that there is a person who's an operator, but there's also a person who is managing the system. Ideally, the person should have an engineering background, because that's how those systems are best managed. And most of the air forces flying 4.5 generation aircraft are going that way, firstly. Secondly, people, my friends here kind of look at me and say, fighter pilot. I also have a BTech. It's given me a lot of insight into a lot of things. Most of the people you find, I won't say most, a majority, no. A certain percentage of people who were operators, especially in my generation, you must realize that. I'm talking about 1970s when, the nuts and bolts are not what we talk about. But there is an understanding, there is an acceptance that a scientific background and a technology-oriented education is a must to be a successful fighter pilot. I'm not a test pilot, but I still believe that having done that when I was a pilot, made a lot of difference to how we look at things.
Thank you. One final question at the back.
Captain Jacob Choi here. Just looking at air power for non-state actors, ISIS recently had a $200 drone dropping grenades in Syria. The US responded with killing it with a Patriot missile. So it's very asymmetric there. Can you talk about non-state actors, the psychological effects of that disproportionate air power, please?
Non-state actors and psychological effect.
Yeah. And the disproportionate economics of a $200 drone getting killed by Patriot.
Firstly, the non-state actors we're talking about, I presume we're talking about, insurgents, terrorists, etc., etc. But whether there is a disproportionate effect of air power when you use it against insurgents, I'm not really convinced. Because what air power basically comes good when you can recognize the centers of gravity of your adversary and destroy it. In an insurgent situation, what is the center of gravity? And that is one place where we have failed in terms of Warden's famous rings. It's not relevant there anymore. Unless you can identify the centers of gravity and prioritize it correctly, depending on the adversary's culture and a whole lot of other issues. So you have 5 centers of gravity that you have identified. Then you have to prioritize those 5 dependent on the adversary. If let's say the adversary is a completely Western democratic force, and you have a list of 5 centers of gravity, and you have the equivalent of that, but from, let's say, from a nation, and you have the same 5 centers of gravity, I can assure you the priorities, if you really do it right, will be different. That's one. The problem with insurgents is that what are their centers of gravity? Whom are you going to go and strike? Especially when you know that the loss of armed conflict, you cannot go and destroy a village because that's what we did in Vietnam. Because we said we have 3 insurgents sitting there. Can't do that anymore. Even then, during the Vietnam War, whether that was a successful strategy or whether it created terror in their minds, no, it didn't. At the end of the day, we lost that war strategy. So air power against insurgents, purely from a combat edge, is not really going to help. You have to use air power for a lot of different methodologies to make sure that a numerically small force can cover a large area by using air power to take them there, sustain them, bring them back. So those kind of tactics have to be used. Firing weapons into insurgents not going to help very much.
Thank you very much. Please join me in thanking Chris Kainikara.